Hey y'all, it's Thursday, May 21st, and Blend is about to shut down. I believe it shuts down sometime on Monday or Tuesday of next week. So I want to remind you that everything is going to move to my website. If you Google the term Marty Math, you will find my website. I actually don't know the name of the website, but it's not that hard to find. I Google myself. I Google that term. I don't Google myself. I just don't have time for that. Anyway, Miss Greiger will also be helping me put together things up on that website so that we can keep people who want to be active throughout the summer. Please know that I'm being completely realistic here. Some of you are going to work on this stuff next week, and some of you are going to wait until the week before school starts. I completely understand that. And by school, I mean college. You definitely don't want to walk into that college classroom without any idea of what's going on with respect to polar, parametric, and vectors. And some of this is stuff that you should have learned in pre-cal. However, when it comes to vectors, most of you have seen this stuff in physics. Fun fact, Greiger, Broussard, Quackenbush, and Toulouse all live within walking distance of me. We see each other out and about all the time. Oh, and Clausen. I don't even know if you know Miss Clausen. Okay, so we're going to start with vectors. A particle moves in the xy plane, so that at any time t, the position of the particle, I don't think that's on there, is it? Oh, the particle is given by x of t equals 2t cubed minus 5t squared, and y of t equals 2t to the fourth plus t cubed. And we're going to find the velocity vector when t equals 1. Well, we have the position vector, so we need to find the velocity vector. In order to find the velocity vector, we need to find the derivative of x of t and the derivative of y of t. Okay, so we find the derivative of x of t and y of t, and the velocity vector, as defined in physics, is the vector such that the vector x prime of t, y prime of t, and at this point in class, I usually rely on students to explain this to other students. For those of you who have not seen this before, which I believe most of you have, this is actually a definition of velocity, or the velocity vector. Okay, so we can go ahead and define v of t and find v of 1. Once you have done that, you need to find the acceleration vector when t equals 1, and the acceleration vector when t equals 1 will simply be the derivative of the velocity at 1. And again, the acceleration vector is defined as the second derivative of the position vector. So here we have the definition of the acceleration vector. Oh, y'all, I forgot to close my little brackets. There is a big, huge discussion in the math community that is super annoying, but you need to brace yourself for it in case it affects you in college. And that super annoying discussion is all around this use of brackets versus parentheses. Some professors want coordinates written in these little angular brackets. Some of them want vectors written in parentheses form. So just pay attention to that and do whatever your prof tells you to do. So you should get an acceleration vector of 230. Now we're going to go through and discover the magnitude or the length of a vector. In order to find the length or the magnitude of a position vector, we just use the Pythagorean theorem, and that will give us our magnitude or length of the vector. Okay, so we just found the length of the vector in general. It would always be the x or the, I'm sorry, let me see if I can think about this out loud. The horizontal length squared plus the vertical length squared, and all of that square rooted, which is just the Pythagorean theorem. So, if you have issues with this, reach out to your friends in calculus, because I guarantee somebody in this room understands this. Not room. Somebody in this group understands it extremely well. I don't want to talk about my physics experience. I think I talked about it once this year. So we get on to the velocity vector, same idea, but we're just going to be looking at x prime of t and y prime of t. And I hope it would be obvious that the magnitude of the velocity vector is the speed of the vector of the object moving along the curve, and the acceleration vector is just, again, the Pythagorean theorem, the square root of the x value, the second derivative of the x value squared, and plus the second derivative of the y value squared. And there you have it. Moving right along, we're going to look at an example. And it looks like this is example 2. A particle moves in an xy plane, in the xy plane, so that at any time t greater than 0, because you can't have negative time, the position of the particle is given by x of t equals t squared plus 5t, and y of t equals the natural log of t squared plus 4. Fun fact, I actually happen to know why it's notated ln, not nl, natural log. In French, natural log is actually logarithme naturel. Anyway, we are going to find the magnitude of the velocity vector when t equals 3. I never knew that teaching math in French would help me understand my math in that sort of way. It was kind of fascinating. Anyway, we're going to find the magnitude of the velocity vector. If we're going to find the magnitude of the velocity vector, we need to find the first derivative and use the Pythagorean theorem to find the magnitude of that velocity vector. P.S. Wouldn't it have been fun if this would have been on the AP exam? However, these are fairly easy for most people across the country, so I understand why it was not on there. We go ahead and simply find our derivatives. Then we put them into the Pythagorean theorem. And the question actually wants to know the magnitude of the velocity vector when t equals 3. So we need to actually put the value of 3 in for t. So here we have it. We have this crazy number. You could make it into a decimal if you wanted to. It would take more time. And you would need to include the fact that it is an approximate speed. What I have right there is the exact speed of the particle at the time t equals 3. Okay, example 3. A particle moves in the xy plane so that x equals the square root of 3 minus 4 cosine t, and y equals 1 minus 2 sine t, where 0 is less than or equal to t is less than or equal to 2 pi. The path of the particle intersects the x-axis twice. Write an expression that represents the distance traveled by the particle between the two x-intercepts. So in order to figure out this problem, I hope that it is fairly obvious that you need to think carefully about what it means for the path of the particle to intersect the x-axis. And the particle crosses the x-axis when y equals 0. So we're going to talk hypothetically here. This is clearly a parabola over on the side. This is your this is your x-axis, this is your y-axis, and at the x-axis, y equals 0. I'm not trying to insult your intelligence at all here. I just know from experience that algebra is the hardest part about calculus. So I'm just trying to remind you of why this is what it is. So we are going to set our y, which was 1 minus sine t, equal to 0, and we are going to solve for t. And we see that t equals pi over 6 and 5 pi over 6. There's a key piece in here that I blew by, and that is we are looking at the values of t between 0 and 2 pi. You need to keep that in mind when you're doing these sorts of problems in college. So this gives you right here where those intersections occur. Now we're going to figure out the distance traveled by the particle between the two x-intercepts. And in order to find that distance, we use the definition, which is in your packet. You probably want to hold on to that packet for the beginning of calculus in college, whether you take it your first semester or your 10th semester of college. Haha, 10th. Anyway, let's hope nobody lasts that long through their bachelor's degree. We use the integral of the magnitude of the velocity and using the definition of the distance, and the derivative of the x would be 4 sine t, and the derivative of y would be negative 2 cosine of t. Then we learned earlier in the year that a particle moving along a line is at rest when its velocity is 0. If a particle is moving along a curve, the particle is at rest when its velocity vector is 0, 0. Okay, sorry about that. I was looking at the wrong problem. We just set x prime of t equal to 0 and y prime of t equal to 0, and we solve blah, 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 find out what time that occurs when both of them are 0, and that should be fairly straightforward. So what you see here is that your first derivative of y can only be 0 when t equals 0 or t equals 2. So you're going to look at your x, the derivatives of x, or your derivative of x, and figure out when that would be 0, and you want either one or both of those numbers or values for t to either be 0 or 2. And lo and behold, when you factor, you find that the derivative of x equals 0 when t equals 2 or t equals 3. So our answer is obvious. When time is 2, the particle is at rest. But now you need to put that in writing. It's not good enough to just have this little answer hanging out in there. That's the tricky part about calculus and college professors. You've got to justify, you've got to write it in writing that you understand what the question is asking and how to properly answer it. Because if you're becoming an engineer, you've got to be able to put everything in context. Even if you're not becoming an engineer. If you're just becoming a receptionist. I don't know. I'm trying to think of something off the top of my head. You've got to be able to explain what you're doing. It's not enough to just sit there and crunch numbers. I don't know anybody who does that. So write down that information. Both derivatives are 0 when t equals 2. Therefore, the particle is at rest when t equals 2. And by the way, my uncle is actually a very famous mathematician, and even he doesn't sit around and crunch numbers. He has to explain himself all the time. Let's see. Onward to example 5. A particle moves in the xy plane in such a way that its velocity vector is blah. At t equals 0, the position of the particle is 7, -4. Find the position of the particle at t equals 1. I actually don't know what I just said, so I'm just going to correct myself just in case. So we have the derivatives, and we have the velocity, and we're looking for the position, so we need to integrate both our x and our y expressions here, which are actually x prime and y prime expressions here. So here we go. We went ahead and integrated using the indefinite integral. And now we're going to go ahead and find out what we know what the position is at 0. The position of x is 7. And we can go ahead and find c sub 1 using this. And in the background, I have some African music. I don't know if you can hear it. But I'm doing that on purpose because normally I feed everybody the last day of school. And y'all didn't get that privilege. So we now know what c sub 1 is. So we actually know what x of t is. And x of t is t cubed minus 2t squared plus 7, which makes x of 1. Plug in 1 for t, and we get 6. We are going to go through the same process for y. And we're going to start with the indefinite integral, solving. Now you see why I push pause. Solving for our c, or a constant. And I'm going to name it c sub 2. In this case, I'm actually going to name these or label these c's differently because in this particular case, these c's did not merge and become 1. It does matter what you call them. So, oops, went too fast. Y of 0 is -4. And when we plug in 0, we get c sub 2 equals -4, or y of t equals 2t to the 4th plus 5t minus 4. And we are actually interested in the position of the particle at 1. Which would be 2 plus 5 minus 4, which is 3. So we can say that the position of the particle at t equals 1 is the point 6,3 on the xy coordinate plane. Okay, well, I miss you guys. I hope you have a great summer. I hope we all get to go swimming at some point. Other than that, I hope that we can see each other one last time in the summer sometime, or you can come back and visit me next year. I will definitely be sending out invitations to invite you to share in some African food, because I make a really, really good what is called groundnut stew. You can actually get it at Wheatsville Co-op. It's just tomatoes, garlic, onions, habanero. I can't quite say that right. Tomatoes, onions, habanero, garlic, ginger, and believe it or not, peanut butter. And I would love for you to try it because you are the first graduating class that has not gotten a chance to try it. Love you, miss you. Y'all take care. Remind text me anytime. I'm going to keep it live. I'm going to keep the remind text. I'm not going to shut it down. Okay, email me, whatever. I miss you. Take care. Bye-bye.